Hi everyone, this is coming to you from Education for All. Today we are going to look at a branch of mathematics that is called infinitesimal calculus. In short, calculus. People just say calculus. That is the name they call it. But its actual name is infinitesimal calculus. Infinitesimal simply means tiny numbers. These are numbers that are tiny, but they are not equal to zero. Very small numbers, very small numbers, but they are not zero. So that is the meaning of infinitesimal. And calculus, as we know, is a branch of mathematics that deals with change and accumulation. That is calculus. In case you don't know, calculus or infinitesimal calculus is just another branch of mathematics, as we have other branches we are already familiar with, like arithmetic. Primary school all starts with arithmetic. That is relationship between numbers with their operators. You are taking numbers, just numbers. Arithmetic is just about numbers with operators. Operators like the signs, multiplication, division, addition, subtraction sign. So if you are adding two things up, 10 plus 5, so 10 is a number, 5 is a number, the operator there is plus. So you are talking here about arithmetic. Then when you finish arithmetic, then you jump on to algebra in your late primary school. You jump onto algebra. Algebra now adds something. Adds up a variable. While in arithmetic you are dealing with numbers, algebra now deals with numbers plus a variable or a letter. Unknown. There is something there that is unknown which you need to find. Yeah. For example, they say 5 bags of cement cost $1,000. 5 bags of cement cost $1,000 or £1,000 sterling. How much will 3 bags of cement cost? So that's how much will 3 bags of cement cost. The cost of 3 bags of cement, you don't know. So that's cost, you put a variable there. If 5 bags cost 1,000, 3 bags will cost X or Y or Z. So that variable that comes into this relationship jumps from arithmetic to algebra. It doesn't just stop that. Mathematics has got a lot of branches. You have other interesting branches of mathematics, like probability. We don't want to talk about statistics because most times they work hand in hand, but they are not the same. Like probability. Again, this is another interesting branch of mathematics with uncertainty. It deals with something that is uncertain. More or less, it's a kind of a lottery. You play, you are not sure whether you are going to win or lose, right? So you are not certain of what is going to happen next, but you know something is going to happen, but you're not quite certain. So that is probability. And then again, we have geometry, which is also another famous branch of mathematics. Geometry, which studies the shapes of objects and the space they occupy. And there are so many other branches. We are not going to talk about all of them. And then what we are trying to discuss today is this other interesting branch of mathematics that is called calculus. The people say calculus, but its real name is infinitesimal calculus. Why? The reason is here because these tiny numbers that are not equal to zero, tiny numbers that are not equal to zero, that is what infinitesimal means. And calculus is a branch of mathematics that deals with change and accumulation. It deals with things that change and things that add up. This we are going to explain in detail as we go along. So which means if we have this one here, we say it's a change and accumulation. You know, accumulation is adding up, add up something. And something that change. So we are in fact claiming that calculus itself is again divided into two branches, two divisions. Let us say divisions. In this case, not another branches, because also you have another one they call variable calculus, but we don't go into that. That's the main thing. We look at these two things, change and accumulation. This change comes with differential calculus. Differential calculus is telling us, is demonstrating to us how fast something is changing. Whatever that changes, how fast or how slow is that thing changing? Then that's in that instance we'll talk about differential calculus. Integral calculus, here differential calculus, people just say differentiation. You will hear this word differentiation. People don't say differential calculus, just say differentiation. We are doing it here for the purpose of explanation. Integral calculus, again, people just say integration. This is about how much has something accumulated, how much has something added up. So these two things, you do one, the other one undo. If you differentiate and then you integrate, so this differentiation does something, integration does the reverse of integration. So it's like the one is opposite to the other, opposite the other. So now having these two divisions under infinitesimal calculus, we are going to take them one by one. We'll start with one, we'll finish with it, then we'll jump to the other one. So tonight, or in this video, we are going to talk about differentiation. We already stated that differentiation is things that change. And what are these things that change? What are the few things? Because there are many. There are many, a lot of them. But we shall just give an example here of what we are trying to say. This topic, let me add something. Calculus. It's a heavy topic in mathematics. Very heavy. So before we start solving problems, we jump straight away into solving problems. It doesn't help a lot of students because they will know the formulas, they will be able to calculate, solve problems, get the answer correct, but they will never really have the proper understanding of what calculus really is. Because when this branch of mathematics was introduced into calculus, it overshadowed all the other branches of all the other branches of mathematics. This came later on. Calculus came later on. It overshadows all other branches of mathematics. It has done a lot of things which I will explain as we go proceed further. So now let's look at differentiation. Integration or integral calculus, we're going to talk about it later on. For now, and in the other videos that will follow, maybe 3 or 4 more videos after this, all this is just introduction. or motivation, you call it that way, before we jump to integral calculus. Differentiation, we already said things that change. What are these things that change? The speed of a car. When you're driving your car, you accelerate, the car moves forward fast. No? That speed is changes. You can't keep the same speed all the time. You must change. You must turn left or right, stop somewhere for traffic light. So the speed changes, right? And what other thing that's why the formula for speed is the distance you travel and you divide by the time you spent to travel that distance. So that is speed. Another thing that changes is temperature during the day and night. Temperature, it can either go up or it goes down. So that is it. It changes with time. It changes with time. It doesn't change like that. It changes with time, from time to time. At certain period of the day, it might be high. Another period of the day, it might be low or medium. So it changes with time. What other thing that changes? You have the battery level of your mobile phone, for example. You keep on using your phone, you can see that um, the battery level or the charging keeps decreasing because of the usage. Yeah. So again, the battery level of your mobile phone changes as well. And again, one other thing that changes is the gradient of a curve from one point to another. The gradient of a curve. A curve in mathematics, when we say a curve, it's so funny. It could be a straight line. A curve, let me just do like this so that you know what I'm talking about. A curve could also be like this. These are all curves. Yeah. So also the gradients, when you say gradients, that is the steepness. You can see this line here is steep. Yeah, it's steep. So that steepness is what is called gradients. So you can measure the steepness. Take these 2 points, you can measure the steepness. Yeah. So that is the gradients of a curve. Or this one here was gradient of a line. And also, you can have the cost of electricity changes as well. The more units you use, you have so many appliances in your house, you put them on all at the same time, you use more units. So again, it changes with the usage. The more units you use, and then your electricity costs will change. It will go high, innit? And then we have again the cooling of a hot drink like tea or coffee. You turn it in a cup, you leave it there to stand for some time. The temperature keeps going down as time goes on. So again, it changes with time. So when you say differential calculus, we are talking about things that change with respect to something else. So now we are going to look at applications of differential calculus or differentiation. Yeah, correct. We're now looking at applications. We have, okay, yeah. Already we mentioned already that differentiation allows us to understand how quantities change and how fast they change. So when you are looking at where do we apply this method, differentiation, this differential calculus we are talking about. How do we apply it? Now we talked about where we can find it in things that change. A car, speed of a car, and the cooling of a tea in a cup, coffee. So, what are its applications? Differentiation. In physics, mechanics, we study about motion of objects. When you study about motion of objects, you have to talk about speed, you talk about velocity, you talk about acceleration, and you can also talk about force. Force. So in physics, we use this calculus a lot, more in physics and maths. This is where calculus is used. But it's also used in economics, in finance, in biology, in chemistry, engineering, science in general. But it's more used in physics and mathematics, this idea of calculus. So velocity in physics, and you know what velocity is how fast something is moving and in what direction it is moving. That is velocity. And acceleration, how fast velocity changes. In economics, we use differential equation or application of differentiation in economics. For example, when you want to calculate costs, you are doing a business, how much you spend to buy your materials, the revenue comes in, you calculate profits. Where there is profit, you should also expect loss and loss as well. So differentiation is applied in the context of economics. Cost, revenue, profit, loss, and all other things else. In biology, for example, population growth or population decline, use differentiation to do that. Calculus, let me just say calculus to do that. In engineering, use its rate of change, things that change, rate of change of things, and also optimization. Optimization simply means maximizing things. So this is what we have for the application of differentiation. Our next topic will be number 2. That is where we are going to see a little bit of mathematics, just a little bit of mathematics. And we are going to talk about the origin of this calculus, who invented this calculus, and why calculus was invented. Because the main thing is why it was invented. And very interesting. So I'll see you in the next video. Bye bye for now.